So we want to prove that the square root of a plus bi plus the square root of a minus bi equals square root of 2 times a plus square root of a squared plus b squared. And in order to do this, let's consider the square root of x plus yi. So if we have this, we can rewrite this as the square root of x squared plus y squared plus x over 2 plus I times the sine of y times the square root of x squared plus y squared minus x over 2. So this is a formula that we will use. For us, it's going to be a plus bi and a minus bi. And just to keep the math simple, I'm going to call the square root of x squared plus y squared r. Because if you recall, with the polar coordinates, x squared plus y squared equals r squared. So the square root of that is r. So now we have r plus x. X here is a over 2 plus I and the sine of b, and then r minus a over 2. Now the sine of b is positive here, so we'll say this is 1. So really, that's going to equal 1, which multiplying by that is just itself. And then the square root of a minus bi is going to be the same thing. It's r plus a over 2 plus I times the sine of now negative b, square root of r minus a over 2, and the sine of negative b is negative 1. So now what I need to do is just add these guys. So on the left side we have square root of a plus bi plus square root of a minus bi equals, we're going to add these two. So it's going to be twice square root of r plus a over 2. And these guys are the exact opposite, so they're going to cancel. And recall that r, we said, up here was the square root of x squared plus y squared. And then plus a all over 2. But notice that's not the same thing here. So what we're going to do is bring the 2 inside the square root as a 4. So that 4 is going to cancel with the 2, and we're going to be left with 2. So what we have is the square root of a plus bi plus square root of a minus bi is the square root of 2, parentheses. And actually here I made a mistake. This is supposed to be a squared plus b squared. 2, and then I'm going to bring this guy over in front. So it'll be a plus square root of a squared plus b squared. And so that completes the proof.